Okay, today on the bench we have a rather rare radio, especially in the condition that this is in. This is an RCA Mark 7. As you can see, I'm deep into it, but I got to a point where I thought it's something video worthy, some just suggestions. So there you can see a little bit of the front. This thing's in about as mint condition as you can get. I think the customer said I guess this was sold as new old stock. I don't think it's new old stock. If it was new old stock, it was not stored in the box because there are a few minor scratches on the cover. But yeah, otherwise, it's really, really nice. Even the top side, you can see there's really no dirt to speak of in this thing. Yeah, a little bit of dust, but yeah, I think it might have just been unboxed, maybe not used. But in any case, he wants this restored. So, replace electrolytic capacitors, the high wattage resistors, check the tubes, the whole 9 yards, and do a transceiver alignment. So I'm in the process of replacing capacitors right now. So, electrolytic capacitors, they're guaranteed they're going to get replaced. Electrolytic capacitor, go bad, just sitting here. Actually, like there's a replacement can cap I'm going to be sticking in this. That cap will go bad sitting on the bench, then it will go bad faster sitting over here on the bench than it will installed in something being used occasionally. Just the process of turning on, I've frequently said, but just the process of occasionally turning on your old radios will extend the life of those electrolytic capacitors. It's a very complex electrochemical process that goes on inside of those. There's oxide layers, and powering up an electrolytic capacitor is actually something that's done during manufacture and not just to test it. That actually helps to form the oxide layers on there. But yeah, but turning it on every once in a while will greatly extend a radio's life. So, something like this, if this customer's not actually going to use it, he should still turn this on and let it on for a while, but maybe once or twice a year. Just take it down off the shelf, plug it into the wall, turn it on, and do something else for a while. It'll last longer doing that than it will just sticking it on the shelf and then come back 20 years from now and you turn it on and yeah, it doesn't work. Or you hear pop when an electrolytic cap pops. But so I'm in the process of changing caps. Now, I haven't actually replaced any electrolytic capacitors yet. I got some of them kind of partially unhooked. It's a little bit challenging working on tube-type radios a lot of times. This one's definitely no exception. Larger radios a lot of times are actually easier. They'll have a lot of stuff on terminal strips, but everything's spaced kind of farther apart, where smaller radios like this, the smaller they get, well, they still got about the same amount of components a lot of times as the bigger radios, so they got to fit all those parts in a smaller footprint. And unfortunately, parts will start to get stacked on top of each other. And a lot of times, of course, the part you need to get to, it's on the bottom of the pile. So yeah, you got to unsolder other parts. Now this one actually wasn't too bad. Probably the only capacitor that's slightly challenging to get to is it does have one multi-section can capacitor right here. It's kind of buried. It's got a lot of parts tacked onto it. This filter cap, it's got an electrolytic cap here, so this is a non-polarized, this is a polarized cap. It's got resistors that run down to it, resistors across terminals, lots of wires. So I wanted to start with that for starters. When you're doing something like this, even if you have, which it's right over here, the schematic for it. So here's the SAM's manual, and yes, this radio is in SAM's #1. That's how old this radio is. Yeah, it was in the first SAM's manual. So yeah, it definitely gives the age of the radio a little bit. But when you're doing something like this, where you're going to have, and let's actually just get a little bit of extra overhead light here. I tend to keep forgetting that this new camera is a light hog. The higher definition cameras need more light to focus so it doesn't get grainy. So, but when you're doing something like this, the can cap, this one has 4 sections. And each section is used. Now some of them only have, well actually, Let me look at it. No, there's actually none of them that have just wires. All of them have wires and other components attached to them. So it's very easy to start unhooking stuff and quickly forget where in the heck all those parts came from. So do yourself a favor. You can go on eBay and get these little, I got a tray of them over here, my manual closed in on. But just little grabby jaws like this. You can get these things in different sizes. I've got several drawers with, alligator clips, and actually alligator clips, I've probably got 20 or something more drawers of those. But yeah, I've got lots of them with different sizes, the little grabby clips. These things are cheap. They're made in China, and I don't use these to make test leads. Absolutely not. They're cheap pieces of junk. But what they're perfect for is when you're doing something like this, identifying where stuff was connected. So I've got this electrolytic capacitor and this resistor, both go to different terminals on the electrolytic can capacitor down there, but they connect to different parts in the radio. So easy thing to do is I can just take, or actually both of those, so two different terminals on the electrolytic can cap, but they both go to the same terminal off, out into the radio. But it's real simple. As I unsolder a part, I just pick a color, put a clip on it. Same thing, take the next part off, put another black clip on it. And then down on the terminal strip where it actually attaches, I'll put another clip. Same thing here. Disconnected this down here, just put a red clip. Now, when I'm changing parts, I normally don't do this. And honestly, even when I'm doing electrolytic can caps, a lot of radios, I've done so many of them, I just know where the wires or the parts go just from memory because I've done so many. This radio, yeah, not so much. You just don't see a lot of these. So, now I've replaced the diodes down here. These are, because of the vintage of this radio, these diodes are very old. Now, of course, they look brand new. I mean, honestly, considering this radio is, what, like 1962 vintage probably? Trying to see if there's a date on the back. Maybe 61, because there is it might actually be like 1961 when it was manufactured. But I mean, this diode looks about as brand new as it can get. But that is on the outside. That's not saying what the condition of the actual silicon, diode element in there is. And just in my experience, a lot of times these old diodes just are not as reliable as modern ones. Back in the day, this was cutting-edge technology right here. A semiconductor. You didn't need a tube, a rectifier tube. You could just do it with diodes. So, yeah, very early. Just a good idea to replace these things. Silicone rectifier diodes nowadays, if you buy them in quantity like I do, you're looking at like a penny a piece. So yeah, it's chump change. Literally, it's less than chump change, whatever chump change is. But yeah, do yourself a favor, just take them out, replace them. But when I'm doing single parts like that, I can take the part out, put the next part in, take the next part out, put the next part in. It's when you get to these parts that can have 5, 10, 15, 20 different things attached to it, that have multiple terminals, you can easily get confused. So yeah, just do yourself a favor, and it doesn't have to be this style clip. You can get regular, alligator clips with different colored rubber boots on them. They work perfectly fine. Shoot, for that matter, you don't have to use clips. You could just put little pieces of tape on here and write something on there. But it's a lot easier to do this than to get the new can cap in there and realize I don't know where anything goes, and then you got to spend the next 2 hours mulling over the schematic and the service manual trying to figure out what went where, and also be aware that those schematics are frequently not exactly 100% correct. A lot of times you're going to find radios, they've done changes to them, circuit changes. And I've seen radios, not specifically this model radio, but I've seen radios before where there can be like 5 or 10 different revisions of, or types of that radio. They all have the same model number. So, let's say if we were using this radio for an example, an RCA Mark 7, there might be 5 or 10 different versions of the Mark 7. They made minor circuit changes, might change a resistor value. They might have added a capacitor somewhere to ground, for whatever reason. But power supply circuits, I've done radios where The original version had a vacuum tube rectifier, diode rectifier tube, and later versions used diodes, and the radios were completely different, but they still had the same model number, and the only service manual is usually going to be the original version. So if you have a later version radio, a lot of times those revisions or major drastic changes in the radio, there might not be anything on a schematic, especially if the manufacturer didn't publish it as well. So just word to the wise, disconnecting a lot of stuff, put some little markers on there just to keep stuff straight. The other thing is, some of you might have noticed, like I said, I have not actually changed any electrolytic capacitors yet. I only have one of one end disconnected, drilled the rivet out, unsoldered this one end, and that's it. None of these capacitors down here are electrolytic. These are all non-polarized capacitors, tubular style. Okay, so inside of that looks basically just like a normal electrolytic capacitor, but it's not a non-polarized capacitor. So it doesn't... For starters, a capacitor like this stores a very large charge. These don't. You'll usually see these used for filtering or blocking, as used in the fashion of using it basically as a blocking, to block DC. So, you may have the output from a vacuum tube attached to one end of this capacitor, but you have DC voltage there. Well, you don't want the DC voltage at the other end here. Well, capacitors like this block DC voltage, so that's great, but it allows the signal to pass through. So, that's one thing these are used for. Another thing is, you'll commonly see capacitors like this tied from a signal source to ground, bleeding off signal, or doing some type of filtering. But these things can go bad as well. Now this radio is not old enough to have the old paper tube capacitors. So used to be back in the day, capacitors looked, well, kind of actually like this. Now this is a metal can. Yeah, this is an electrolytic, but they were kind of similar to this. You'd see a cardboard tube with wax or some kind of glue on the ends. So kind of like this, but instead of a plastic body, it would be a paper, a waxed cardboard tube. If you see those, you're guaranteed you want to take those things out of the radio. If a radio's got them in there, trust me, the caps are old enough that they're bad. They've not only changed value, but there's a very good chance they're probably almost a dead short inside. They're just so dried out. But these are no exception. Now these I'm not 100% sure. I'd have to break one open to see. I don't think these are paper type inside. I think these are a poly style capacitor. So what I'm talking about there is whatever the dielectric material that separates the two aluminum plates, because this is basically just two wrapped up layers of aluminum foil, but it's what separates those two plates, which are attached to each of the ends. The old days, and that's why they're called paper caps, they actually had paper, which is just what they use in electrolytic capacitors. Even today, brand new electrolytic capacitor, that's what's separating the aluminum layers in here is paper. Now in these, it's soaked in a kind of a nasty chemical fluid, the electrolyte. But at some point, this style capacitor, they stopped using paper, and they started using different types of poly. You often hear it referred to as, poly caps. But it's polypropylene, there's all different types of stuff they can use. They can even use mylar and micas and all kinds, anything that's an insulator. But there's two different types down here. So this style here, there's a good chance this is probably some type of poly cap. But I disconnected a few of them to test the value of them. Didn't check them for shorts, just checking with a capacitance meter. And yeah, pretty much they're all out of spec. These are old bumblebees. Now a lot of people think, oh Mike, why are you taking the bumblebees out of there? Man, I always hear about people saying about how good the old bumblebee capacitors were, and guitar guys and audiophiles, they always want bumblebee capacitors in their stuff and they don't want them changed. Well, for starters, I'm here to tell you, if they don't want them changed, they're fools. I can guarantee you, if it's an original old bumblebee capacitor, it's bad. These things are not reliable. Nowhere close to even being reliable. And I can show that with, what I got, three of them here. So we can actually we just test all of them. And yeah, I can't, I forgot to change this over. Let's see, system, display, invert, and yes, now you can see the display. It's the only thing I always forget, that the the meter, the way it's set up there, when it's a white background and black numbers, you can't see it. It just blinds the camera, even this new one. Now, it might, if I zoomed in on it, this one would probably be fine, but my old one, man, it just really didn't like it. So let's start with this one. Actually have several 0.1. So there's 1, 2, 3, and 4. So there's 4.1 microfarad capacitors. The only difference, these are smaller than these, is the voltage rating. So we can see right there 200 working volts DC, where these two larger ones are 400 volts, or 400 working volts DC, but still the same value, 0.1 microfarad. So let's just test them, see what they are. So 109 nanofarad, which would be 0.109. So that one's actually fine capacitance-wise. We'll check the next one. And we can see 127. So that's 20. So if it's 100 nanofarads is equal to 0.1 microfarad. So 20% tolerance would be a maximum of 120 nanofarad, or no less than 80 nanofarad, and we're reading 126, so yeah, out of tolerance. Here's another one, another 0.1, 118. So it's high, not quite out of tolerance. It's 18.2% out of tolerance, but it's your high. But it's still just it just squeaks in there. Another 0.1, and this one's 128.10. So that's 28%. Again, out of tolerance. So if I find one or two, yeah, I'm just going to change them all, because the other ones probably aren't far behind. We've got a smaller value one here. So this one is a 0.0022 microfarad, which would be 2.2 nanofarad. And we're showing 3.19, so that's like horribly out of tolerance. Yeah, this is 2.2 nanofarad. Keep losing contact here. Get the probe tip back on there. So this is a 2.2 nanofarad capacitor, and it's measuring 3.2 nanofarad, so it's 1 nanofarad high. Yeah, that's way out of spec. Now the black beauties, oh yeah, that's where it gets good. Just because they might look nice and shiny on the outside, that definitely is not an indicator. The first thing is, a lot of times when you look at these, you're going to find they're cracked. And actually one of these, I got to hold it up here so I can see it. I got to find it first. And it's going to be the last one, isn't it? Oh, where in the hell is it? I know I saw one of these had a crack line going through it. Oh, actually it was this one. I don't know if this will focus. I gotta find it again. Yeah, it's a little more visible right there. Let me get a pointer. But we get the camera to focus right there. There's a crack, starts there, comes down, goes. I'm trying to look through the viewfinder here. Let me move the light some maybe. Oh, for Pete's sakes. There, you can see that line right there. That's a crack. It runs down. There we go. You can see it runs right across the color bands, on down the whole way through to the other end. So the exterior protection has been breached. So you're guaranteed moisture can get in there. And I'm not talking about it's raining, it's like there's a rain cloud opened up on the underside of this radio. I'm just talking about humidity will get in here. So this one is what? Of course you have to decode that. Red, orange, black would be what? 2, that should be a 20, or no, 2.2 nanofarad. I think. Yeah, 2.2. Or is that 22? Yeah, actually that's 22 nanofarad. And that would be, let's see, that would be a 20% capacitor, and this one's rated at, that would be, I guess, let's see, that would be 400 volt rating. So let's just see what this thing measures. Holy smokes. Yeah, like I said, this is a 22 nanofarad capacitor, and you can see it measures 34. So kind of like this little guy here, it's way out of tolerance. The next one, we have what? Orange. Is that orange or brown? Orange. So orange, orange, red, black, blue. That would be 3.3 nanofarads. Again, plus or minus 20%, and let's see, blue would be 600 volt rating. So this one, so remember, this is a 3.3 nanofarad, and we can see 7.5 nanofarads. This one's a, well, actually it's surpassed it. It's more than 2 times its rated capacitance. It's 3.3 nanofarad rating. 2 times would be 6.6, so yeah, this thing's like enormously out of spec. And this last one, what do we got? Brown, black, so 1, 0, red, so that'd be 1 nanofarad, and yeah, it'd also be plus or minus 20% at 600 volts. So 1 nanofarad one measures, that's even worse yet, 3.6, 3.5 nanofarads. It's 3 times out of tolerance, high. So there's just a prime example of why just because parts look good doesn't mean that they are. So that's why you see lots of new, yellow capacitors. Now you might be thinking, Mike, yeah, but you're taking measurements with a multimeter. It has a capacitance tester, but you're using long leads. Yes, I am. The long leads, yes, they do add some capacitance, but they're only adding in the range of like picofarads worth of capacitance into the test circuit. Here's an example. This is the last cap I have to put in here to replace that big black one in there. So this is a, what do we have here? 224 would be what? 0.22 microfarads. So let's just see what a new one measures. Look at that. 0.225 microfarads. So that just shows you right there that it's not the meter, it's not the test procedure that's out of spec. It's the capacitors that are bad, because here's a brand new one that clearly measures well within spec. If I can get the lead, we'll get on there. Come on. There we go. 0.225. So yeah, 0.225 microfarad, and it's a 0.22 microfarad cap. So yeah. So I guess that's about it for right now. Of course, I'll show you more throughout the radio, but yeah, I got to get this CAN capacitor replaced. Like I say, I've already changed all the rest of the capacitors in here. There's only a few high wattage resistors. So, there's 1 there, 2. I got like 2 over here. So there's 4, 5, 6. There's like 6, maybe 7. Now that actually, I just saw that. Oh, where did I put my pointer? I set it down on the bench. That is not a resistor, so easy trap for young players working on old stuff. That looks like a resistor to the untrained eye. Ooh, them some stiff solid wires there. That looks like a normal axial lead, carbon composition resistor. It's not. That is a capacitor, and there might even be more than one in here. No, that might be it. Just taking a look through the radio here. And it looks, of course, again, I'm kind of looking around the camera. Yeah, it looks like that might be the only one. But yes, that is a capacitor. That was a common, especially in radios older than this, this is actually what you would normally see for smaller value capacitors. Now, larger values, you would have seen stuff like the Black Beauties, if it was a Sprague. You'd see ones like this, except they'd be in a cardboard tube. But for the lower values, that was actually a common package style for capacitors. So, yeah. Don't go taking something like that out, looking at the bands, going, okay, you know, figuring out what that would be in resistance value and slapping a resistor in there, and yeah, you'd let the smoke out, because you got to remember, non-polarized capacitors don't pass DC voltage. Well, you go sticking a resistor in place of something that's meant to be blocking voltage, you might let the smoke out. The last thing is these high Qs capacitors. Now, of course, there's ceramic disc capacitors in here. They can go bad, and occasionally they do, but it's very rare, especially for this this style here. Now, some of the ones I've seen that have a darker brown dip coating on them, I have seen those go noisy before. Not all the time. I think it has more to do with the conditions of what the radio's been stored in over the last, like 60 years, 50 to 60 years. But the ones that have a darker brown coating on them seem to be a little bit more hygroscopic. They're like a fibrous material, where this is more like a high heat ceramic type coating. Those other ones, like I say, they go bad. So yeah, the only other type of capacitors, I mean, other than air variable maybe or something like that, but as far as like axial lead caps go, are these here. These are high Qs. I will not be changing these. These I do know for a fact are not paper capacitors, and I've never had a problem. I don't think, honestly, I have ever changed a high Q cap before. So it's basically similar to that, just a lot more reliable. Got to remember this is the kind of the changeover point where things were starting to go from vacuum tube to solid state, for starters. Components were also starting to drastically change how they manufactured capacitors, resistors as well. As tube type went away, most carbon composition resistors, at least in this form, went away. We started going to film type capacitors. So instead of a compressed block of carbon material in there, it was a piece of ceramic, basically bar stock, with some resistive material on the outside of it, wrapped around like a barber pole on the outside with a coating over it. Film type resistors are very reliable. The old carbon composition resistors, not so much, and especially the large ones. As I always say, the large ones, they're large for a reason. They're getting really hot, so they need to dissipate more heat, so those are always the ones you're always going to want to replace. The small ones usually will be fine. They do occasionally go bad. What I will usually do is, radio like this, I'll replace the high wattage ones. And once I get all the work done to it, I'll fire the radio up. As long as when I do the alignment, the radio is working fine, I'm not even going to check all of these little small resistors. Now, some of them may be out of spec, but just because the resistors are out of spec, a lot of times does not adversely affect the performance of the radio. So, the receiver, transmitter, oscillator circuits, whatever it might be. A lot of times you'll find these resistors are really high value, like right there. I can see the third band is yellow, so I know this resistor is in the hundreds of thousands of ohms. So, if it's a 5 or 10% resistor, well, I've seen resistors like this get out of that 5 or 10% resistance range, but it's still a resistor that's in the hundreds of thousands of ohms, or, if that third band is green, you're in the mega ohm range. It's such a high value to start with. Even a drastic swing doesn't really affect the circuit. A lot of times those resistors are in a bias circuit or in a feedback circuit, so as long as the previous stage is getting some feedback, that's all it cares about. Like I say, a lot of times the tolerance on these smaller ones isn't as critical as these large ones. The large ones, when they go out of spec, they can cause some serious problems, because the large ones are usually being used to reduce a voltage level. So their whole job, and that's why they're big. They're usually dropping a lot of voltage across them, so they get really hot. And if they get too far out of range, if they go low in range, which I've seen them do, when they go too low in range, well, now they'll let too much voltage through to the next circuit, and then you could damage later stages in a circuit. So, like I say, big ones change, little ones, they're usually fine. If you fire the radio up and you do have problems, then you can go in and troubleshoot and find maybe one or two faulty ones. Or if you've got noise, I wouldn't suspect any noisy resistors in this one, because this one doesn't look like it's really ever been used much. But an old nasty radio that's been baking for 50 years, yeah, you may have some resistors that have also gone noisy. So you may have to go into an audio circuit and troubleshoot a noisy resistor. But, yep, so there we go. There's the progress so far. Next thing I need to do is start unhooking stuff off, the rest of the stuff off of that electrolytic can cap down in there, and get that desoldered and pulled out and stick the new one in there. So, and that is a very time-consuming process. You know, a lot of people think, changing parts, that's easy work. No, not so much. Trust me, completely replacing an electrolytic can cap probably will take me as long as replacing every other single part that I change in this radio. So changing all these other capacitors, any resistors I'm going to change in here will take the same amount of time as just changing that one can cap, because they always have a lot of stuff going to them. You know, they're mounted permanently to the chassis. The capacitor can is soldered. There's 4 tabs that go around there. They're soldered to the steel chassis. So it's just a lot more work. And of course, the new capacitor I'm sticking in there has a clamp, so I've got to drill 2 holes to mount the clamp to. It's just a lot of work. So, in any case, I'll be back. Probably by the time I get back, unless I get all this work done and find something that I need to do some troubleshooting, probably the next time you see it, it'll just be a working radio. So I'll be back. Okay, so I've got all the electrolytic capacitors, all of the paper caps, and the resistors changed in it now. So your high wattage resistors, not all of them. Like I said, there may be some that may be out of tolerance as far as the lower wattage ones go. A lot of times in several circuits it just plain won't matter. If there is a problem with one that's out of tolerance and it is causing a problem, I'll find that out when I do the transceiver alignment. Now anytime you do something like this, it's a good idea, especially if you've done this much work, you've changed a lot of parts. Especially if you've done some complicated stuff. So, you know, if you're just changing a capacitor at a time and a resistor at a time, you're only taking one lead off, or 2 leads, one on either end at a time, and installing parts one at a time, yeah, there's not too much chance of goofing up something and hooking up something incorrectly. But when you do stuff like the multi-section electrolytic can cap, so this one, there's lots of parts, you know, attached to this one capacitor, because this has 4 sections. So, you know, there's resistors, which these were just left on here because they were going to get replaced anyhow, because this is a 2 watt and this one's a 1 watt. So they're going to get changed anyhow, so just left them attached to the cap. Same thing with these 2 capacitors. This non-polarized cap and this electrolytic cap going to get changed out, so I just left them attached and was able to just pull them up through while they were still attached to this. But anytime you do something like this, there's a good chance you could have screwed up. And trust me, it happens to the best of us. That's why we want to carefully turn our radio on. We don't want to just replace all of this stuff like this. You know, lots of chances for screwing something up, hooking up wires incorrectly. When you're replacing electrolytic capacitors, installing them backwards. Just all kinds of things you could do wrong. So the first thing is check over your work visually, and I did find one solder connection I had missed, because I usually will change like all of these capacitors, so you know, all of these non-polarized caps. When I changed them, I'll just come in, desolder them, install the new ones, but not solder them in yet. So I'll desolder the old one, unwrap the leads, pull the old one out, stick a new one in, and I'll just do that for all of them. And then I'll come back and solder them. And I did find, I think it was this connection right here, was not soldered. So, but that's why you want to check over your work. Last thing you want to do is turn it on and find you've got a problem, spend a bunch of time troubleshooting the problem just to find out it's a self-induced problem because you forgot to solder a part in. Excuse me. The other thing is, like I said, we've done a lot of work. Well, not we, me. I've done a lot of work in this area. All of these other parts were just changed out one at a time. So, and when it comes to resistors and non-polarized capacitors, it's not like you can, well, the non-polarized ones you could stick in backwards. It's not going to cause any major problems. Most people would just replace these. You'll notice they have black bands on them. It's not that they're polarized, but the outside foil on these capacitors is attached to one end or the other. Just manufacturing, just the way it happens. Now, manufacturers, when they install these in a radio, and it doesn't always matter. It depends what the capacitor is being used for and it doesn't even need to be a radio. It can be a television, could be anything electronic. But sometimes they want that outside foil attached to a certain terminal. So it actually matters which direction you have this installed. Reason is that outside shield can act like an antenna. So if you're putting this in something in part of the receiver circuitry, if you install it with the higher potential on one side in the wrong, basically the wrong direction, the outside foil, because remember the capacitor is made up of two layers of basically aluminum foil separated by an insulator, the dielectric, but that outside foil can act like an antenna. So if you hook it up backwards, it's not going to blow up, nothing bad's going to happen, but it can induce a little bit of hum or noise into your audio, both transmit or receive. So that's why I just check them. Usually if you get a little bit of noise, it's not going to really be that bad, but it's simple. You just take a scope, you hook it up and see, basically hold the capacitor, hook a ground clip up and your scope probe up one side, and then flip the leads and see which direction you see the most static on the screen of your oscilloscope. When you see the most static, you know that you have this probe tip attached to the outside foil end. So I just then mark them with a marker. But like I say, we've done a lot of work over here, and this is an area where we can put in parts backwards and it can cause bad things to happen, and we don't like bad things to happen. So we really, really want to take our time and carefully check over our work before we go plugging it in. So have your schematic handy. Once you're done and you think you're ready to go, pull out the schematic. Go through and just double check all the wiring. Make sure it's done right and all the components are in a proper orientation. Same thing with diodes. I replaced a couple of the original diodes in here, so I want to check and make sure that they're in a proper orientation as well. I've done that. I'm now confident that everything is soldered in circuit, and I'm confident that I have everything hooked up correctly. So now it's time to fire it up and see what happens. Now I have not even turned this on originally, when it still had all of those parts in it. So, but the customer said new old stock, and it was apparently supposed to work. So I'm going to assume there weren't any problems. And looking in the radio, yeah, like I said, I think he bought it with the understanding it was new old stock. I do not think it's new old stock. I just think it's about as close to new old stock as you're going to get. It saw very, very little use. So what I want to do is hook this up to my isolation transformer over here. And actually the first thing I need to do is turn the voltage down the whole way. So, and I'll plug this in over there. And then I want to turn on, actually, let's see here. I'll probably hook up maybe 2 voltmeters. So what I want to do is I'll leave the tubes in it for right now. I'll turn it on and just slowly bring the voltage up a little bit. If I see the voltages starting to rise, that I'll show you in a second here, that I'm going to be monitoring, it's fine. And I'm also going to monitor because that isolated variable power supply over there also has a built-in amp meter and watt meter scale. And I'll watch that. As long as the power doesn't surge up, that there's a big draw, basically short to ground or something like a cap in backwards, as long as I don't see anything like that, I'm confident I can just keep turning it up. But what you want to do is basically check the high voltage power supply circuit. So you want to attach a voltmeter. I will usually hook up 2, maybe 3 voltmeters when I first turn a radio on, and check the main supply rails. So I'm probably, the way this one's wired, I'll probably use 2. I'm not too concerned about the negative bias supply because that's a fairly low voltage here. But right after the rectifier diodes, it should be around 260 volts. And don't take these as written in stone. Anytime you look at a service manual like this, you have to remember every single component in this radio has a tolerance. could be 1%, 2%, more than likely old radio. It's going to be like 5, 10, or even 20% tolerance. Like those caps, like I showed you how far they were out. But those were originally 20% caps. So, you know, the manufacturer's spec for anything in here can be off by several percent, because every single one of these components in here has a tolerance. And if they're all, let's say, low in tolerance, well, that may let more voltage through, so the voltage may be a little bit higher. Or if all of the resistors, let's say, were high in value, we might actually find our voltages are lower than what's listed in the manual. But as long as they're somewhere close to it, we can feel pretty confident that we don't have any major problems. So I'll probably hook up the 1 voltmeter right here. So we have our primary winding over here, our secondary. This is going to be high voltage AC coming out here, and see it's two red wires. But after this rectifier diode right here, we should see 260 volts DC. So I'll hook up 1 voltmeter there. That'll, you know, basically checking with these electrolytic capacitors, you know, as long as I start to see a positive voltage here, I know the caps aren't in backwards, as long as, because they're not, it's not being shorted to ground. And I'll probably attach like to the 230 volt rail, because this has basically a voltage divider circuit here. There's 260 volts, then there's a 100 ohm 1 watt resistor, there's a tap off for the 250 volt source. Then there's a 1000 ohm 2 watt resistor, which drops it down to the 230 volt rail. So I'll hook up one here. I'll hook up one here right after. Actually, I'll probably just hook that up. That should be. Gotta see how I got this wired. That should be right at. Be the 1000 right at the can cap there. And then once I get the voltage up to like maybe halfway, somewhere around 100, if I, you know, as long as I can get up to where I see about half the DC voltage I'm expecting, around 130 volts DC, I'll then switch over and I'll check the negative bias supply here to make sure that I have bias supply. So that's a fairly simple circuit. What they did here, as you can see, it's actually just tapped into the AC side, goes through a DC blocking capacitor right here, 0.1 microfarad, and you can see that says 100 volts AC. Here's the diode to ground, and then after this point it'll be a DC voltage after this diode. So yeah, I'll just somewhere in here probably, let's see, white and green wire, and what did I say that was? 560K. White and green wires there. Green, blue, orange. So there's our 500 and green, blue, yellow. Okay, here's our 560K right here. That attaches to a 1 meg, which in turn goes to the 5.6. So yeah, so what I'll do is I'll attach probably right after, at this junction right here, which would be right here in between the 560K and the 1 meg resistor, and I'll just make sure that it looks like the negative DC bias supply voltage is coming on. So let's get some probes out here. I got the meter. Actually, I need to invert the screen on this so you can even see it. Let's see, system, display, invert, and yes, that is visible now. So the chassis on this is the negative DC negative ground potential, so I can attach the ground clip to anything basically metal on a radio like this, and that is DC ground. So we can just clamp on there, and get out a grabby clip here. And let's see, that was that diode where it hooks up to what? 100 ohm resistor. So that would be right here. And then I'll turn on an analog meter over here. So I'm going to be, you won't be able to see both of them in the same camera view, but I'm turning this one on over here as well. Let's see, that's already on the 500 volt scale. Get that out of the way. And again, I'll just hook the negative up down here to the steel chassis. And I had said I was going to hook that one up at the filter cap, so the lowest of the high voltage sources, which was at right after the 1000 ohm resistor. So that should be, yeah, right there. And I've got my probe with the 100K resistor in line, because this probe has a switch on it. To use it in AC, you slide it back for direct. When you're in DC, you slide the switch forward. That's just the way the meter works, but yeah, I was just checking to make sure that's right. So I've got both meters hooked up. Now what I'm going to do is make sure, for starters, radio's turned off. I'm going to turn the squelch full clockwise. That is actually off. So old tube radios, just in case you're not familiar, a lot of old tube radios, the squelch works backwards. So if you ever get an old radio like this, you turn it on, you're familiar with modern radios, you turn the squelch completely counterclockwise so that you can basically hear everything. And then to turn the squelch on, you would rotate it clockwise. They operate backwards in a lot of your older CB radios, your old tube type radios. This is one of the earliest. So yeah, this is one of those. I just know that. I own some of these myself. But yeah, so make sure, because that way, once we get the voltage up to probably somewhere between 1/2 to 3/4 voltage on this, we'll probably start to hear sound coming out of the speaker. So squelch is off. It doesn't really matter what position I have the switch in. I don't have an antenna hooked up. Like I say, radio's turned off. I'm going to turn on, and of course, isn't that nice? That probe's right in the way of the meter. I don't know how well you can even read a display. Try and get it a little bit. There, you can. Yeah, that looks pretty good. I can read that in the viewfinder. So I'll flip on the isolation transformer over here. Turn the volume control on-off switch on. And what do we got? Well, it flashed a few millivolts for a second. So let me start turning it up. And why is the meter, oh shoot, I've got it on AC. Must have accidentally hit the button. Because say, what the heck is going on here? Because hey, I'm turning the voltage up. I'm watching over there on the other meter, and I'm seeing a positive voltage over there, but I wasn't getting anything here. I had the meter in AC. Okay, so there's 56 volts and barely any readable current draw on the isolation transformer over here. So I'll keep turning it up. Now I'm going to turn the volume up to about 1/2 to 3/4 of the way. So once the receiver circuits and the audio circuits get to the point where the tubes start to conduct, we should hear some sound. Like I say, that'll usually be somewhere between about 1/2 to 3/4 of the voltage. And if you remember, I'm looking for about 260 on this one when we're at line voltage, and I'm looking for about 230 volts on this probe here. I'm seeing 170 volts DC there. I'm starting to see a little bit of current draw on the meter. Oh, I hear a hum coming out of the speaker. I don't know if you can hear that, but there is a little bit of noise there. Remember, I've got the voltage turned up, or the volume turned up a good ways. And if we look over at the other meter, we can see that we do have voltage. So I've got this in the 500 volt range. So that would be the upper scale on the DC reading. So that's about 140 volts right now. So about 20 volts lower than what the main supply is, which is what we would expect to see, because At full voltage, it should be approximately 260 there, and 200 and what I say 230 on the other one. So there's going to be like a 20 to 30 volt difference. So that's looking good. We've got our voltage drop. Now I'll usually let it sit here at that about lower voltage, somewhere around half operating voltage for a few seconds, just to make sure if there's any problems in here. I'll give it a chance to smoke test, but I don't want to smoke test it at full voltage. So, I'm sitting here, I'm also still monitoring, watching the voltmeters in case I start to see either of the voltages drop or increase drastically, and everything's looking fine, everything seems fairly stable. So, and actually I'll actually turn the radio off for a second, because with this probe it does have a little bit of exposed, because the voltage, as you see there, it drops off really fast. There's enough resistance attached through these capacitors that the stored voltage then disappears within a few seconds. But I want to turn it off while I unhook this, because this alligator clamp, as you can see, has metal exposed, and I don't want to go grabbing onto 130 volts DC. I can get a little bit of a tingle, but what I'm going to do is now attach that over here, which is the negative bias supply, and I'll switch my probe on this meter. I can switch it so that the main probe is now the minus, because that's why it has a positive DC and a minus DC. So when I flip that switch, what that does is that turns the ground clip into the positive lead, and it turns the main probe into the negative lead. And that voltage is fairly low, so I'll flip this to the 150 volt scale and turn the radio back on. And good. So that's on the 150 volt scale, which is the upper DC voltmeter scale. And you saw it slowly rose up there a little bit again. And it's starting to drop back down. Remember, this is tube type. The tubes have enough voltage being supplied to them, maybe to not work completely, but they are starting to conduct. So once the heaters came on, they came to basically as hot as they could get at the reduced voltage. The tubes started to conduct. You saw the voltage started to swing up and then drop back down until it stabilized. But actually, it's the bottom scale here. So 150 volt scale. So we're showing about minus 70 volts right now. So we're looking good there. So I'm going to turn it off again. Wait for that voltage to bleed off. I'm going to take the probe back off. I'm confident there's no problem there now. And I'll come back over here and reattach to this filter cap. Get my meter switched back over to the 500 volt scale. Main probe as positive. And turn the radio on again. Turn the volume up about half to 3/4 of the way. And I'll continue to increase the voltage. Remember, we're looking for, by the time I get up to about 110 to, and I hear sound. Good sign, we got static. Turn that down some. By the time we get to 110 to 120 volts AC in, we should see approximately 260 volts on that meter. So there we go, 120 volts in. We've got 264, doesn't really matter what the fraction is, about 264 volts DC right after the rectifier. And we're showing 220 volts over there. So looks good. And as you can hear, we do have sound. And it looks like we're drawing about a 1/4 amp AC, that is. So I'll turn it off really quick. I'm going to disconnect this probe here because it's going to kind of sticks up there, just kind of gets in the way. I'll turn it back on, and let's hook up an antenna and see if it actually receives anything. That is, if there's anything on air. There's really... It's right at the end of the day. It's actually early evening now, so the skip is gone and the evening time good time gang hasn't come on yet. Well, always a good sign when you hear human voices. Okay, so it obviously receives. Now the next thing is, does it transmit? So, turn on my 1040 over here, flip over to dummy load. This radio also, or the customer also sent with this radio the original microphone. So you can see there, it's the original RCA microphone. Yes, this is the mics they used to use back in the day. You have to remember, this radio is about 1961 vintage. It's in Sam's manual, CB number 1 manual. So yeah, old radio, so old type mic. And this microphone was used by more companies than I have fingers and toes. You'll see this exact style microphone with any number of little name tags on there. I've got these microphones for some of my old Johnson Viking radios. Or not Johnson Viking, the original Messengers. Yeah, you name a radio company back then, there was a good chance they might have had at least one or two of their radios probably use this style of astatic microphone. So let me get this critter plugged in. Haha! I think we have output power. And we do. Not a heaping helping of it, but we do have. Audio 1, 2, 3, 4. So we're about 2-watt carrier. So we can do about 5.5 or 6 watts. And of course, I haven't done an alignment to this yet. I haven't done anything other than just change parts, so I haven't done any adjustments. So looks like our part swapping was successful. So now I'll flip this over. I'll let it warm up for about a half hour. Let it get good and baked. Tube radio, I want to let it completely warm up. I'll just temporarily set the top cover back on it and basically let the temperature stabilize so all of the crystals in this can warm up, because remember, this is crystal synthesized. But after that, I'll pop the cover off, I'll do an alignment to it, and it should be all done, because there's not really a lot to clean up on this. Like I say, it's like brand new, so probably next time you see this, it'll be turned over and will probably be reassembled. I might show the top again once I get the alignment done, but yeah, I'm pretty much done. It's really not much left to do other than the alignment, so I'll be back. Okay, so here she is all back together now. Really wasn't much more to show on the inside. You'd seen the top before. Not a lot to look at there. A couple IF tuning cans, transformer, electrolytic capacitor, and a vibrator, and a relay. So yeah, not a lot of business going on up top. And as you saw before, it's really clean. But so I got her back together, just a quick wipe down. Yeah, the cabinet's in really good shape as well. It didn't need anything but just basically a dust brush and a little bit of glass cleaner on a microfiber towel just to get fingerprints off, really. The top cover's in really nice shape. I mean, probably the only imperfections in this radio are in the top cover. 2 little spots, one there and there. That's it. Yeah, I mean, they just don't get much nicer than this. Also includes, the mint condition microphone. Also has the original mounting bracket there with the original knobs. So, oh, and even rarer yet, when the customer sent this, he not only sent the AC power cord, but the original DC power cord as well. So yeah, there's only one wire on the DC cord. What they expected you to do was you just plug this in the back. This would go to your positive line, and then there's just a screw that sticks out the back of the radio, which when you're hooked up to AC, ideally you should have that hooked up to a ground. But when you're using the radio DC, as a mobile application, you'd have your positive going to this wire, and then the negative would go to the ring terminal on the back of the radio. Does have a built-in fuse holder. Yeah, man, they just don't, if I can get untangled here, they just don't build fuse holders like this anymore, man. Solid metal. I mean, that's a fuse holder. And as far as current, when you're using this on DC, I think the Sam's manual, just kind of going off memory here, I think on 12 volts, this radio used 4 amps. Shoot, book's laying right here. Why guess? What did we have? 12.6 volts, yeah, 4 amps. So if it's running off of 12.6 volts, which is what this would run off of, because this does have the 12 volt vibrator in it. There were 2 different vibrators. Where's the parts list here? So yeah, you could get 2 different vibrators, a 6 or a 12 volt, and this has the 12 volt vibrator in it. So the radio would need to run off 12 volts, but yep, just like I say, that just makes it even more rare. Comes the original DC power cord. That's probably one of the first things, at least nowadays, that would be one of the first things that gets lost is the DC power cord. So basically a complete unit. So in any case, there you go. There's a RCA Mark 7 radio phone, and I'm not sure if I mentioned it or not, but the actual model number is right there. It's a CRM-P3A-5. So hope you enjoyed.